Day grade 8s. In this video, I'm just quickly going to go over some of the tips and tricks and techniques we need to use when we simplify algebraic expressions with exponents. Now, before we can actually start looking at examples, we need to recall a few things we've already done previously in the grade 8 here. First thing we need to recall is our exponential laws. Now, when we think about exponential laws, some of them that we're going to use the most is the fact that when you multiply two numbers with the same base, you are allowed to add their exponents together. For example, if I told you x to the power of 2 times x to the power of 3, since the bases are the same, you are allowed to add the exponents, and that gives you the same answer as x to the power of 5. We also need to recall the exponential law that when you have two numbers with the same base that divides, we are allowed to subtract those exponents. Another one, and this is going to be the one that we use the most in this video, is the one that states that if you have values inside of a bracket and you raise that to an exponent, then to simplify this, you're allowed to take this exponent and multiply it into the bracket or all the exponents inside of the bracket. So meaning this is the same as saying x to the power of n times m times y to the power of n times n. We are also going to have to recall that when we add and subtract algebraic terms, we are only allowed to add like terms. Well, add and subtract like terms. For instance, when I give you x squared plus 3x squared, those two terms are like because they have the same variable and they also have the same exponent, meaning you are allowed to add their coefficients, which is 1 and 3, and that would tell you that this is the same as 4x squared. Notice that how when I added them, the exponent did not change. But if it was, um, let's say x squared times x to the power of 3, then using the exponential law number 1 that we just recalled, we're allowed to add those exponents to give you 5. So when you multiply, the exponents change. Now, how does this come into a role when it comes to simplifying algebraic expressions with exponents? Well, the best way to do this is to think about examples. For instance, we can ask you to square a value such as x to the power of 3. Now, normally in mathematics, when we talk about a square, this means we should think of raising something to the power of 2. So what am I actually asking you in this example? I am asking you to take x to the power of 3 and then raise it to the power of 2. So in other words, I am going to ask you have to take x to the power of 3 and you have to raise it to the power of 2. And now this is where exponential law number 1 comes into play again, because now we need to remember that since this is something raised to the already raised to an exponent raised again, we know that these two exponents need to multiply. So this becomes x to the power of 3 times 2, which gives me x to the power of 6. I can also ask you to square something like a to the power of 4, b to the power of 3, which, and again, this just means I want you to take this x to the power of 4, b to the power of 3, and I want you to raise it to the power of 2. So how this would look like is as follows. You would say a to the power of 4, b to the power of 3. You're going to take that, you're going to square it, and now again, we have an exponent on the outside of the bracket, so we should know, because of exponential law number 3, that this exponent on the outside can multiply with all the exponents on the inside. And this would tell you that this is going to be 8, not 8, a to the power of 4 times 2 times b to the power of 3 times 2, which gives you a to the power of 8 and b to the power of 6. Now, something we can also maybe ask you is to also square something like negative 5 to the power of, or times b to the power of 5. Now again, like in all of the previous examples we've already did, we just want you to square it. So to find the solution, we are just going to say negative 5b to the power of 5 squared. And now you need to remember that that squared counts for everything inside. So this negative is, there's two of them, so negative times a negative, because of that square, that gives me a positive. You are going to have to take this exponent, multiply it with the exponent of the 5, so it becomes 5 to the power of 2 times 1. And you're also going to take that exponent and multiply it with the exponent of the b, which gives you b to the power of 5 times 2, which then ultimately simplifies to 5 to the power of 2 times b to the power of 6, which is the same as 25b to the power of 6. Now, same thing we can apply here is I can also ask you to cube. I can ask you to cube something like b to the power of 3. Now, when we hear the words cube in mathematics, I want you to start thinking of something like something raised to the power of 3. So what am I asking if I want you to cube b to the power of 3? I'm essentially asking you to take b to the power of 3, and I want you to raise it to the power of 3. And now again, we're just going to apply our exponential law just like we did with the previous example. So this 3 multiplies with the exponent on the inside. So this is the same as b to the power of 3 times 3, which gives me b to the power of 9. I can also ask you to cube something like b to the power of 2, c to the power of 3. And again, because I'm asking you to cube, it means I want you to raise it to the power of 3. So you're going to take this little expression, you're going to say b to the power of 2, c to the power of 3 to the power of 3. And you're again going to apply exponential law number 3, meaning you're going to take it, multiply it in, and then you're left with b to the power of 2 times 3, which gives me 6, and c to the power of 3 times 3, which gives me 9. Um, and that is essentially some of the things in a nutshell. Now, of course, what I can also do is I can make these expressions a little bit more tricky looking. For example, the following. I can ask you to simplify the following. I can ask you to simplify 4a to the power of 3, b to the power of 4 to the power of 2. Now, at first glance, this looks as if it is going to be complex, but we just need to remember exponential law number 3, which says that if I have a bracket that's raised to the power and everything inside of that bracket is just multiplying or dividing, what I essentially can do is I can just multiply that exponent on the outside with all of the exponents on the inside. So this becomes x to the power of m times n times y to the power of m times n. And remember, this only works if everything in the brackets add or subtract, not add or subtracts, multiplies or divides. Now, taking a look at this example that I have here, this is 100% fine to take this exponent and multiply it with all of the exponents on the inside. So this is going to become 4 to the power of 1 times 2 times a to the power of 3 times 2 times b to the power of 5 times 2, which simplifies to 4 to the power of 2, a to the power of 6, b to the power of 10. 4 to the power of 2 can then further be simplified to 16a to the power of 6, b to the power of 10. I can also give you an example like the following. We can ask you to simplify minus 3b squared 3 plus minus 2b3 to the power of 3 to the power of 2. And I can ask you to simplify this. Now again, we need to remember our BODMAS rule because that always applies, meaning before we can add and subtract, we first need to get rid of the brackets first. And again, everything in these brackets are multiplying and dividing, so we can safely take this exponent on the inside and multiply it with all of the exponents on the inside. Now something that I want you to quickly take note of in this first one: anytime you have a negative number raised to an uneven number, the answer will always be a negative. So negative times a negative times a negative gives me a negative. Then we're going to have 3 to the power of 1 times 3, that gives me 3. And I'll have b to the power of 2 times 3, which gives me 6. Again, just applying the exponential law. Then for next, we're just going to take this exponent, multiply it with all of the exponents on the inside, and from there we are then going to say, okay, but this is a negative times a negative because of the square, that's going to give me a positive. This 2 becomes 2 to the power of 2 because 2 times 1 as the exponents, and then we're going to have b to the power of 3 times 2, which gives me 6. Now from there, these can then simplify, and you'll have negative 27 b to the power of 6 plus 4b to the power of 6. And now if you take a look at these b's, they're the same b's with the same exponents, meaning they are like terms. And because they are like terms, we can now add them together. And this will give me minus 27 plus 4 will end up giving me minus 23b to the power of 6. One last example before we sign off. The next example gives me 5a to the power of 2 minus 8a to the power of 2 to the power of 2. Now something that we were tempted to do is wanting to use this exponential law, but remember, this exponential law only works if we multiply or divide. In this case of this example, I am minusing. So we are not allowed to use this exponential law. So that means we first need to see if we can simplify what's inside of the brackets. Now, if we quickly take a look inside of the brackets, we have a to the power of 2 and a to the power of 2, meaning again we have like terms. And because they are like terms, we know we can add them. So 5 minus 8, that's going to give me minus 3a to the power of 2 to the power of 2. And now it is safe for us to use the exponential law, because now everything inside of the bracket is just multiplying. Now again, what I like to do is I like to solve my signs first. And this to the power of 2 means I'm going to have two negatives, and a negative times a negative gives me a positive. Then I'm going to take this exponent and I'm going to multiply it with all of the exponents inside of the bracket. So it becomes 3 to the power of 2 times a to the, 3 to the power of 2, because 2 times 1 gives me 2, and then it's going to become a to the power of 2 times 2, which is 4. I can then simplify this 3 to the power of 2 to become 9, and then we have a to the power of 4. And that, in a nutshell, is everything you need to know about using exponents or simplifying algebraic expressions with exponents.